Well, let's do a little review of section 5.1. So we'll convert, let's say 60 degrees, let's convert this to radians. So we'll use dimensional analysis, put that over 1, and we know there's 180 degrees per pi radians, and radians are a unitless measure. And now the degrees divide out, and 60 goes into 60 once and into 183 times, so that equals pi over 3 radians. So now number 2, let's convert, let's see, 3 pi over 4 to degrees. So we'll multiply by 1 in the form of, using dimensional analysis again, 180 degrees over pi. Another way to write 1. The pi's divide out. And let's see, 4 goes into 180 degrees, 45. The quotient of 180 degrees divided by 4 is 45 degrees, and 3 times 45 degrees is 135 degrees, and we've got that one. Now let's see. Oh yes, here we go. 3. If first of all, we have to recall this, S equals r theta, so distance about an arc equals the radius times the angle, and so correspondingly r equals S over theta, and theta equals S over r. Now let's see what we have here. Theta, we're given that theta equals 1/3, and S equals 6 centimeters. And we have to find R. Well, here's the guy we're going to use. So R equals, S is 6 centimeters, divided by, and that's 1/3 radians. Radians are a unitless measure, so we don't have to write it down. And divided by 1/3 radians. So now, when you invert and multiply, you get 6 times 3 centimeters, which becomes 18 centimeters. Now let's do one more. And here it is. The mean distance from the moon, and this is on your worksheet, by the way, and this is 5.1, one of the review problems. And the mean distance from the moon to the Earth is, and I'll call it the radius, is 2.39 times 10 to the 5th miles. Okay? And assuming that the orbit of the moon about the Earth is circular, moon about the Earth, so this is the radius, is circular, and that one revolution takes 27.3 days, so T equals 27.3 days for the moon to revolve about the Earth. Find the linear speed of the moon. Oh, okay, the linear speed of the moon. Well, we know this, that linear speed velocity equals distance divided by time. And we also know this, that S equals r theta, where theta equals 2 pi. 1 revolution is 360 degrees, or 2 pi radians. So therefore, the velocity equals theta is 2 pi. The radius is 2.39 times 10 to the 5th miles. And we're talking 27.3 days. And now we've got to convert days, because we have to write this answer in miles per hour, so we have to convert days to hour. So there's 1 day per 24 hours. And now the days divide out, and when we compute this product and then carry out the division, what we wind up with is 0.023 times 10 to the 5th miles per hour, which equals, moving that decimal point over 2 places and writing this in scientific notation, 2.3 times 10 to the 3rd miles per hour. That means that's moving at 2,300 miles an hour. Whoa! We're done.